So will it
So
append that new file fully or just a part of it, the chunk which was modified?
it's a full, as I said, that if you write in the middle, that you will have to upload the complete file. I mean, if that will help you, so think like the GFS is kind of a Google S3. It's not a file normal file writing system. It's a Google F3 S3, sorry, or Azure storage. If that help you.
Yeah, I mean, so if that is the case, then multiple people are modifying the files, then there will be multiple appends, right?
Yes.
Then how do they merge the final changes, right? For example, you modify in line number one, I modify line number 10. Then, for me also whole 1 GB file is uploaded, for you also 1 GB uploaded. How does that identify that these are the two
I'm
lines which
saying that
changed?
it's not editable. You write the data, you write to the append that chunk to the end of the file.
Yeah, that's correct, but still have to merge, right? We have to merge as it also says over here that we have to
Merge.
merge the, yeah. So merging part, how does that happen? Merging part.
No, merge what? So
Merge the
you are
final
still not.
changes.
I think you are still thinking that you have a same text file. I open that, and same text file you open that. It's not like that. It's like you have a multi GB data, maybe a training job or AI training job is running and it's producing some intermediate data, and you just go and dump that data.
I'm thinking of big files only.
Yes.
So see the description if you read right, what it says, it is useful for implementing multi-way merge results and producer consumer queues that many clients can simultaneously append to without additional locking. Right? If you can just that line itself is telling a lot of things that multiple appends happen, then it says without any additional locking. Um, so I'm thinking like how does the final merge happens? Right? If since people have different changes placed on that 1 GB huge file, is it even a practical scenario for
So,
GFS? And
so on that note, I found out one of the like point that they how they implement the mutation order to it. I think looks like the primary is responsible for setting up some mutation order. Can I share the screen?
Sure, but I mean, I do still have feeling that, I mean, Richard, you are not visualizing that how that data is, that you are still thinking that the single file, the one user, you are still in that mindset that they are mutating the same file or editing the file. Let's say you are working on one document or some part of that document, and someone is working on the some part of the document. When I upload my document, my part is there. Then when somebody else upload their document, it will go and append to that what I already uploaded. The third person upload their part, it will go append to after that.
on the top of that, on
Yes,
the top of the latest
yes.
merged copy.
It's not going to modify my part.
Mm.
So you mean like in writing in appending in blocks? So
Exactly.
since
So
the
it's
block will
not
be
like
appended.
we are working on the same document and I made some changes, and you are also working on the same document, made some changes. This file system is not for that purpose.
Okay, okay, okay. I think I
So
yeah.
yeah,
Since
so
this
this
is
this file system is like that. Okay, I'm I like I'm a job, one job. You are a one job. I'm third person is another job. Our job is to actually, let's say, download some web page from internet and dump it into some container. Forget about that. It's just a container. You just throw those downloaded page into that container. So whatever I downloaded, I just actually upload it to that container. The same way you downloaded some pages and upload down dump to that container. Or if you think that like how actually you upload data in the S3.
Yeah, like it's more like basically a block. Like file is nothing but a collection of blocks, right? Like
It's a blob, yes.
yeah,
Yeah, I think we will get
can
that
I?
clarified as we move forward. Yeah.
Yeah, can I share the screen?
Yeah,
Can you stop sharing?
sure. Go ahead.
Yeah. So, are you able to see my screen?
Yes. If you can make the font a tiny bit bigger, that would be great, if possible. But no, it's okay.
Yeah. Is it visible?
Yes.
Okay. Yeah.
Just yeah, just if okay, is it possible for you to make it a little bigger? The
Yeah. Let me check.
font? Because yeah, the diagrams of print is really small, right?
Yeah.
Oh, that's great.
Yeah. So the part I wanted, Ruchir. So the part I wanted to share is, um, so basically, there is some kind of leasing that happens. So so what they are talking about here is when a mutation occurs, we are talking about an operation that changes the content or a metadata of a chunk. So basically, whatever changes are happening, which are append only, right? So for that, it has to occur on all replicas, right? So if it has to occur on all replicas, that means the master has to basically set the chunks that needs to be appended or that needs to be modified, right? So there is some order that
Hmm.
this serial order is something which is being set, and the master is actually setting the serial order for appending the operation, appending the mutations or the records to different chunks. And then even if multiple clients are um, like appending to the file, all of them will be channeled through the master, right?
Right.
So I think that's how they are taking care
Yeah.
of the flow, where uh, yeah. So I think here they are talking about like the master will allocate a lease to one of the chunk server, and master will tell the replica locations, and then through that basically most of the append operations would pass in. Does that help?
Yeah, it does help. Yeah, so basically we are actually identifying, master is identifying which block that change is belonging to. It will append it, and behind the scene it will just overwrite on the top of the current
Yeah,
chunk, right? Yeah, that is how I'm thinking.
yeah.
So
And then
not, not
here they are
let
talking
me
about.
clarify, it's not the block, Richard. So master just actually tell you that okay, where you have to whenever you say that okay, I want to actually append this data to um, you provide the file name, then the master node just actually tell you that okay, go and write to this server, and that is the chunk server. It just give you the IP address of that chunk server. So master maintains some metadata for each file where it actually keep track that okay, up to that point this server has that data. After that, this server has that data for this file.
Right. So what does that chunk server do? Then chunk server will
So chunk
overwrite,
server
right?
is just chunk server just holds the data, like whatever data we are supposed to store, right? Chunk server just holds the data, but here I think somewhere they said that um, there will be some serial order that will be set, like the primary assigns the consecutive serial numbers to all the mutations it receives, and apply the local changes in serial order to the chunks. And then it says the primary chunks then forward the serial numbers to all the replicas, and replicas will follow these serial numbers to apply the changes in serial order. So
Right.
basically, the replicas will be the uh, uh, will hold the data, right?
Right. Absolutely. So based on the serial order,
Yeah,
they will make the changes on that file.
yeah. So even though multiple client will be invoking the write operations, all those write should go through master and primary, and then primary is basically allocating the order to the operations
Right.
through the serial numbers.
Yeah, and then replica will identify where in the file I have to make changes, and in the order of the serial number, it will make the changes one by one, right?
So
So,
the it's append only, right? So it doesn't matter,
mhm,
like in the file it will always be like in like append only
yeah,
operation, right? But which chunk to apply when is will be decided based on the serial order. Does
okay.
that make sense, or
Yeah, it does make sense. Yeah.
okay? Okay.
So, which to when? So, when is another question. Like when it happens is probably immediately or sometime later.
Yeah,
Yeah. Okay. Okay. Thank you guys for sharing this. This is a nice article. If you can just share that on
yeah,
Sagar, that would be helpful.
sure. I think they have like so I think if I'm not wrong, they called it something like lease, like I like some sort of a leasing or something like that that they call. So the primary is actually leasing the chunk servers for time to time. Not sure like what's the logic or what's the like the details of why they call it leasing it, but something like that, and this comes under that process. Yeah, so here it is. I think here they have mentioned like the master node establishes a lease for a copy of chunk, which we call primary chunk. The serial order of change that corresponds to that chunk replica is controlled by the primary chunk.
Is the primary chunk is always on the master? No, right?
No, I think it's one of the chunk server which will hold the master chunk or the primary chunk.
So it's actually changed time to time. So
Yeah,
it's actually like the flow is like that. So the client library first communicate with the master,
yeah,
and then master return you that information and lease lease for that, initiate the lease and the information about that which one is the master chunk server at this time. Then client communicate start the communication with that, directly start with that um, master or primary chunk server, and it will start accepting that until the lease expire. Once the lease expire, that master may depends on the situation at that time whether the that particular chunk server is actually holding lots of data or not. It may um, put the next lease on the same server or some other server.
yeah.
Is
I
the
think
leasing is
they
only for
try to make
chunks?
it randomized. Like the lease they want it to expire is because they want to avoid a single point of failure, or like so they want it to randomize the lease amongst multiple replica copies.
it may not be a single point of failure, right? That may not be the main use case. That could be that, but that may not be the, because maybe
So
like to make the to increase to improve the latencies, right?
So, yep, we can call it improve the latency, or we can call it avoiding the bottleneck. So in Hadoop paper or some in HDFS paper, I think they have mentioned somewhere like that they want to avoid a single node which is allocated as a primary chunk could be slower, right? Like due to some hardware reasons, that data node could be so slower. In order to avoid that blocking the whole system, they want to keep rotating it.
Yeah, actually, that's what my question was. I was asking. So is the lease, right? The chunk primary, what is that? The master chunk, right? So the master will be there and master chunk will be there. Master chunks, is it master chunk is always so when master chunk is there, right? Still the master will accept the new request, right? Not master chunk, right? For other chunks.
Yeah, so there is master node. Master node is like the, like actually the leader, what we call it. And then primary chunk is something different, or the master chunk is something different. Like, so master chunk is like, so the master node will assign the lease with one of the chunk server or one of the chunk which we call as master chunk or the primary chunk, and that
Now,
lease will
what
keep
about the next
rotating, but
request?
the master
Where it
node
will
will
go?
remain same.
Where it will go? It will it go to the master chunk or will it go to the primary chunk? The
I think
further request.
master is responsible for assigning and revoking the lease.
No, no, I don't think so. Right? Assigning and revoking the lease may not be master may or may not be the responsibility, right? But what I'm asking, right? So you assign a primary chunk. Or, so what Praveen was saying, like any request comes, the request directly will go to the primary chunk, right? So then, so is it that Praveen? I don't.
Sorry, what were you saying,
What
Srini?
I'm saying, right? So here we have master once the lease is accepted by other node chunk server, right? That means here, right, master is not responsible for taking any incoming requests, or master is not responsible for taking this chunk request. Is it like that?
Yeah, so the purpose for here the master is different. The purpose for the master is just to actually uh, allocate a chunk server for your request and tell you that what is the IP address for that chunk server where you can write your data.
Yeah.
No data flow through the master.
Yeah. So, Srini, if you read this line, it says master node establishes a lease for a copy of the chunk, and that could be any chunk server or any chunk on the chunk server.
Okay. So for the another chunk, if the data is coming for the another chunk, right, that has to go to the main master, right? Or no?
I believe every single chunk will have the primary chunk, right? Like, and the second. So for, let's say there will be primary chunks mapped with master node. So whenever the data comes for another chunk, master will reroute that to its primary chunk of that particular chunk ID.
Okay.
Maybe
Yeah.
probably
I got
we can read this later whenever we will wrap this up, because it looks like a good article, and they have also explained in detail about the atomicity like we were talking about. And I think they have also talked about writing in parallel or appending in parallel, which I think this will be able to help answer your question in detail maybe.
Yeah, I will go through this article
Yeah.
to understand this.
Okay. Yeah, let's continue with our discussion earlier.
Sagar, please, you put it in the WhatsApp, right? Group,
Yeah, yeah,
the.
yeah, yeah, I will put it. Yeah. So shall we continue? So I think yesterday we cover from until clusters, right? So we were supposed to start with cluster and cluster server today,
Hmm.
chunk server today. Yeah. Uh, can we rotate if anyone wants to read?
Yeah, I can read.
Okay. Just make sure if you read a bit slowly.
Yeah. GFS is organized into a simple network of computers called a cluster. All GFS clusters contain three kind of entities: a single server, a single master server, multiple chunk servers, many clients. The master stores all metadata about the system, while the chunk server stores the real file data.
Yeah, can you have a look at the diagram also?
Yeah, sure, sure.
Just,
So the client sends the metadata request, which goes to GFS master server, which has metadata and not the actual data. And from GFS master, it goes to chunk server. So basically, GFS master server gives the instruction to which chunk server it should go, guess.
yeah.
And then
So
client directly writes to chunk server.
yeah. So are you guys able to see the similarity with Kafka we covered, like message queues that we covered? So generally most of the storage system has a metadata server, like it's one of the primary component. So metadata server actually maintains the record of all the chunks or all the basically files or the data therein. And then the client is should then read out the write request. So write request always goes to the storage server or like the chunk server here. Or in Kafka we had partitions, right, like data partitions. So the write request was always going to uh, uh, the partition itself, but we have the metadata server where it gets where the chunks are located.
Yeah, so here, for example, if you have 10 GB file, then if you break it down into small chunks, right? Each server would get some part of that file, right? Maybe like first chunk server would got 4 or 5 chunks, another server would got another 5 chunks of that same file, like that. They would distribute the chunks across the cluster, and and that and chunk server would be responsible for making changes on those specific chunks which it holds, right?
Yeah. So um in a zoom, let's say if we zoom in on that part, so I think a single metadata request just get the response in the form of all the chunk IDs, basically chunk IDs and chunk ID URLs or chunk ID locations. So there are a couple of operations in happen in between, but they have some resolutions. Like if we relate this to Amazon S3 kind of thing, so a single file request is resolved uh, um based on the bucket ID, based on the location or like maybe some directory, and then that is then resolved into the chunks or chunk IDs, and then those chunk IDs and are then resolved into the actual URI where the chunks are located. So there are multiple operations that happen in between, but the final outcome is that the client gets the list of chunk URIs or the chunk server URIs where, and then in serialized format, like which chunk to pass to write to which one, and then basically it just goes on like sends a one by one request to write those or append those to the respective chunk locations.
Right.
This is what, right? Based on the earlier diagram, right? So once we get a metadata request, and then the master server will lease the chunk server, right? So
Yeah.
then it returns back the IP address of the chunk server, and the client will directly write into the request, right? That is
Yes.
the same thing, right? Yeah.
Yeah.
And when there is a GET request of any file read, right, it will just read from all of this server. Master would know that where my on which chunk server this file is residing because it has that master information of all the chunks.
Yeah.
It will just merge them and provide it in the byte sort of response to the
So
client.
I would say the master here, like the GFS master server, that's slightly is like it could be like called as like, so another way of looking at it is like we will have an application server, like it's nothing but an application server where our GFS application, basically GFS system is invoked, and it has a metadata, or sometimes this metadata could be located in memory or on the same instance, but sometimes the metadata service could be separate service altogether. So it could talk to the metadata service to just get the list of the chunks, and then it has to keep the heartbeat with the chunk server too, so that it can then update the metadata server or metadata service based on that. So this master server is nothing but the application server here, I believe.
So there is one
Even
read request. So there are two read request arrows, right? One is going to the GFS master server. There is another read write request is going directly to the chunk server,
Yeah.
right?
So
Oh, which one is that? Which is directly going to chunk server? I think we will get more understanding on that when we read. So maybe we should read that first.
yeah, yeah,
Yeah.
so one point, adding to your point, right? Not adding to addition of your point, right? See the master server, right? It has all the details of the chunk server. The heartbeat may be just the health of the chunk server, right? Why do you need to get updated information from the chunk server, right? Because the master has already that data, right?
yeah, I mean to say heartbeat only, because if one of the chunk server dies, then it has to update the metadata, like metadata, that metadata service, or like whatever metadata is
Yeah,
there,
that's for only for the health checks, right? That is whether,
only for the health checks.
yeah,
Yes.
yeah.
Any doubts, anyone? This could be slightly confusing, so it's okay if even if it's any doubts or like.
Yeah, it's little bit going over our head because I have no reference of for the first time I'm visiting this topic.
Yeah,
So maybe reading through different documents and as our discussion goes further, it will gain more clarity.
yeah. By end of this PDF, I think you will be able to connect all the dots. But it's good that we are putting like placing these dots early on, like so you will end of the day will be able to internalize it. So don't worry about it.
So
Or
the
else,
one common thing across the storage, right? Master server, which holds the metadata, and
yeah,
even the S3, right, directly can write into the data. So that link is a common, but how it is internally organized is different.
that's what actually I was trying to like highlight this ever since we started the sessions. Like we literally spent 1 or 2 weeks just to understand the metadata servers and the master management, cluster management in Kafka as well, like in distributed message queues. So this is exact same thing there, and in a way like Cassandra also does that, but it just does it leaderless way, like where it has the gossips which keep passing the information. But this is a common theme across most of the, that's what actually I wanted to highlight. That's a good point, yeah.
But actually, it's not out of the topic, but Kafka side, right?
Hmm.
The partition itself is a storage, right? Because it's a message. I mean, it doesn't hold the long. It doesn't hold the. I mean, like every message should be 10 MB or 20 MB, some size, right? But this is quite a different use case, right?
So I mean to say like the topic partitioning is what the chunks here are. Like here we have chunks, right? There we have topic partitions. Does that make sense? Like
I mean, similar, but not the end use case is different. I mean, yeah, it's maybe like we can imagine that way.
Yeah, so the theme, as in, I mean to say, like there will be a application service, or there will be a client, there will be a application server or a master, and then there will be a metadata service, and then we will have a partition data. So this is the block diagram or a high level diagram that I wanted to actually generalize, like a
But actually,
template.
in Kafka, right, the user can specify topic and partition, but here we can't. The user doesn't have that idea, right? Here,
So actually the topic and partition, that is like for the namesake here as well, like the buckets we have, right? The buckets actually act like buckets, or like that actually acts like a topic here. So even the bucket will have multiple files in it, and each file can have multiple chunks. So just the way we have different messages, here we have different chunks, and a single topic partition can have multiple messages, right? Just like that, we have bucket with different files, and bucket will itself have multiple files, and then and then we are breaking it, or distributing it across multiple servers.
okay.
Yeah, I think can we read maybe?
Yeah.
Yeah, I'll get more clarity. Yeah.
Chunk server. Chunk server stores chunk on local disk as regular Linux files and read or write chunk data specified by a chunk handle and byte range. For reliability, each chunk is replicated to multiple chunk servers. By default, GFS stores three replicas, though different replication factors can be specified on a per file basis.
So what they are talking about here is like the replication factor will be per file basis, and regular files and read or write chunk data specified by chunk handle and a byte range. So file metadata. So for each file, uh, it could have three or two chunks. So this F1 file here.
I think
Uh,
it's like inode architecture, inode, right, in the Linux system, right?
Sorry.
I think they are talking about it similar to the inode in Linux.
Mm,
So basically, a file is divided. First file is F1 is divided into three chunks, and it has like a unique chunk handle, which is 1, 2, 3. And the second file has 4 and 5.
Yeah, I think this makes sense. This diagram. Um, if you see that, right, the replications. I mean, sorry, not replication. Chunks C1, C3, and C4. So master server has the metadata information for each chunk. It just tells like on which chunk server that specific part is residing, right? And it has a replication factor equal to 3. Means you will see number 1, which is a right, 3 times, right? Which is located on 3 different servers because it has a factor as 3. So this makes sense, yeah.
So what are the blue color? I mean, orange. What are the yellow, blue? What are those?
so these are chunk servers. So basically, I think this C1 is a chunk server, C3 is a chunk server, right? And
Yeah.
C4 is a chunk server. So
Yeah.
this
What is
chunk
that whole?
number one,
Whole one.
yeah. So one is a chunk, like the orange is a chunk, and then this orange chunk is distributed, is stored on three replicas basically, C1, C2, and C4.
Say one.
So orange chunk you can see like on C1 there is a orange chunk, C3 there is a orange chunk, and C4 there is a orange chunk. Then the second chunk is replicated on C2, C3, C4. So the purple chunk is there on C2, C3, C4.
Yeah, I got it. See, it's a similar to kind of inode where you'll say where a start address and end address. The same way here, you will say in the that chunk what is the start address and what is the end address for this file. So they will maintain it. Okay.
So I'm not aware about inode. Is it like the basic file system in Linux, or any particular thing like?
No, it's a node actually. Like when how it gets stored.
Okay.
I mean, any request the F1, right? The file, right?
Uh-huh.
The file means the file handler, right? And then it says like from which byte to which byte in the underneath on the file system, right? Where that the data resides, right? So that gives the whole map. It gives it. It's kind of a metadata that is.
Okay.
So the
Okay.
similar way here, right? Chunk master server has for F1 file, right? We have three chunks, and chunk one goes to the no three chunks, and chunk one goes to the three different replicas, right? So that will be maintained. The metadata is maintained, right? In the same inode, also we maintain that.
So this inode is based on a single disk, or
Yeah,
there
it's a
is
single list. That's what it's not a single list. It's file system. Okay,
okay, okay, okay,
it's a file system. I mean, it could be anything right underneath.
okay, makes sense.
So with this replica chunk server also resides on the same chunk server as the other chunk servers. Is that so? Because I see chunk handle 3 that is a part of chunk server 1, 2, I believe. Yeah, I mean, yeah, 1, 2, and 4.
Uh,
These are the cluster. This is a cluster, right? So on this cluster, there are multiple servers. So one of them is a master, which is talking to different servers. Each server is representing one chunk server. That is how I'm thinking. Yeah, I mean, what do you guys think?
Actually, in a traditional
Yeah.
ladder follower, right? One ladder and multiple replicas, but here, right? It kind of this is kind of a in consistent hashing, right? Kind of virtual partitions, right? This is,
yeah,
but it is not that model. That's it. But this is very complicated architecture.
yeah.
We haven't read it fully though, we are just
Yeah,
yeah, I think we should read it first
yeah.
and then we will know more. Yeah, so that's
Because
pretty
Asha,
interesting.
but Asha, is your doubt clear, or like, or we were trying to point to this replica chunk server as in like separate than these?
I mean, yeah, technically, when we see replicas, those are separate servers, right? And not a part of actual servers. Here I
No,
can see, yeah, here
it
I
is
can
part
see.
of. So it is part of the basically it is part of the cluster only, but
Mhm.
uh, every single server will have a chunk, right? Like, so consider this as like these are the data nodes, or these are these are the storage servers. So storage
Mhm.
servers are nothing but the chunk servers, and this is server number 1, server number 2, server number 3, server number 4. These are basically the storage servers, which we are also calling as chunk servers.
Yeah,
It's part of the cluster, the same cluster basically.
yeah, yeah,
You can imagine so four replicas. You can imagine this way: four replicas we have. We can say, oh, those replicas are C1, C2, C3, C4, and but it is not it is not a same replica. Like it is like distributed across all the replicas. Every chunk is kind of.
So each one would have a different, they're physically separate, right? So basically, they would have a different IP address.
Yeah.
Yeah, that way you can think, Asha. So that will,
yeah.
yeah.
Maybe as we read, a lot of things will get
Mm.
clarified.
Actually, I don't know. Maybe like these are really physically separated nodes, or maybe VLANs are. I don't know. We'll have to see that.
So these are physically
Yeah, yeah.
separated.
These are
C1,
physically
C2,
separated. Yes.
C3, C4. You can imagine that's the data node, and yeah, four servers and three replicas.
Okay.
Yeah.
So one reminder, we are close to 7. So what should we do? Should we continue for a while, or and then move, or
Yeah.
because looks like master will take some time. But yeah, up to you
So
guys.
real quick, I would say just we just read through this no, like
Mhm.
without discussing, so that whatever we have discussed so far, we could internalize, and then tomorrow again we will start with this if anything is missing. So just
Yeah.
Yeah. Okay, I can read this if
sure,
Mm.
go ahead.
yeah. So, master server is the coordinator of a GFS cluster and is responsible for keeping track of file system metadata. The metadata stored at the master includes name and directory of each file, mapping of each file to its chunks, current locations of chunks, access control information. The master also controls the system-wide activities such as chunk lease management, locks on chunks with expiration, garbage collection of orphan chunks, and chunk migrations between chunk servers. Master assigns chunk handle to the chunk at the time of chunk creation. The master periodically communicates with each chunk server in heartbeat message to give it instructions and collect its state. For performance and fast random access, all metadata is stored in the master's main memory. This includes the entire file system namespace as well as all the name to chunk mappings. For fault tolerance and to handle master crash, all metadata changes are returned to the disk onto an operating log. This operation log is also replicated onto remote machines. The operation log is similar to a journal. Every operation of file system is logged into this file. The master is single point of failure, hence it replicates its data onto several remote machines so that the master can be readily restored on failure. The benefit of having a single centralized master is that it has a global view of the file system and hence it can make optimum management decisions, for example, related to chunk placement.
Um, I'm I have a feeling like this could be like a this is like pretty old like write up, because I think they're talking about master's main memory. I think I have seen most of the like architectures like which have a separate metadata service.
Yeah,
Uh,
technically, yeah, to separation of concern, right? For that, they do. I'm not sure if that is the right word, but the high level architecture we saw, it also talks about metadata being part of master server, right?
so yeah,
Actually, here, right? If you take a zookeeper, right, that acts as a master, maybe.
zookeeper won't be able to coordinate the chunk allocation, right? Or basically zookeeper is not an active instance, right?
No, no.
It's
I mean,
passive,
I'm saying
right?
kind of. It is not exact zookeeper, right? Because we are storing everything in the master, right? Metadata is stored in the master memory, and that is a persisted. Um, because if you have another service connected to this, right? Again, that's I mean, like how you persisting it, right?
Yeah, so I have seen like Cassandra being one of the most sought after metadata service in most of the file system or object storages applications, like, and then because it scales almost up to the like also like up like very high to match up to the throughput requirement here. So uh, and then there is a local caching as well, like in memory storage, and Cassandra being like the metadata service. Does that make sense, Shrini? Or
Actually, oh, two things right here. I mean, like two different Cassandra underneath storage system is completely different. How the data it's kind of how the data being stored. That we don't know, right? We never discussed that, right? When we always one layer above we were discussing it.
No, no, I'm talking about only the metadata storage. Not. So they are talking about the all metadata is stored in the main memory, right? And then they are talking about it's flushed into operation log. So
Operation log is nothing but a commit log.
commit log, correct? So instead of these being pushed into commit logs, there could be separate metadata service in which these metadata information could be persisted.
Can
But
we?
but will not that increase the latency, because now we need to take the chunk data and now there is one more service involved,
Yeah,
right?
but fault tolerance is also one of the uh,
Yeah.
important
Could
consideration.
be, but this system was designed more
Yes.
than 20 years ago.
Oh, okay.
So,
Yeah,
so
makes sense. Yeah,
they were not having that luxury what we have today.
yeah, makes sense. Yeah.
So this architecture is not reflecting today's architecture. Then? It looks
No,
like. It looks
no.
like, yeah, but shouldn't we not? Shouldn't we looking
So
at the current
if we
architecture?
look at like any object storage design, right now they are much more mature than this is what I could like I have seen in my experience, but I might have limited information. But like as in like even the lease structure is being changed to something where they have clear partitions, or like some they call it like context or bucketed way, versus like right now the lease thing is much more complex, or that could still cause a single point of failure. So like most of the like object storage system, maybe we can, once we complete these and hdfs, I think hdfs is improved form of gfs, if I'm not wrong. But
SDFS is improved, but it's not latest. So now even the Azure storage, there is a paper on that. So that's again, that paper is more than 10 years ago published. And the latest one is from Meta, Tectonics.
okay.
That is the system, what the unified system, mm, they implemented. Uh, Azure, oh sorry, S, AWS S3, they did not publish any paper for their internal system, but the fundamental is same. I mean, based on my experience, what I do have in object storage. So the fundamental is more or less same. Few things definitely, I mean, over the period of time has been improved and optimized,
Mhm.
but in general, the gist is the fundamental idea is almost same. Like you have to chunk split your data and store these chunks, and then somehow have some magically store this metadata service which will actually put your give you the information. Say like if you want to read data from offset 100,000 to offset 200,000, so they can figure it out that, oh, which chunk server has that information, and get that information directly from there. So they provide you all these tree kind of a hierarchical structure through that metadata service that has been improved with some system now. More still, I believe that, I don't know. I have not used any object storage, to be honest, personally myself. What they provide, say like whether they have provide the flat namespace or the tree structure based namespace like S3. Do they have?
I think yeah, they do have chunk trees. I was just
No,
looking.
I mean can you create a directory structure in S3,
Yes,
or
yes.
just a flat namespace
I think they
directory?
are.
Google storage a flat structure.
Yeah, in S3, I think they give virtual directories. They call it
Okay.
virtual directories,
Uh-huh.
not actual. They are not like a physical directories or like per se. They call it virtual directories. So, um, like the bucket I was talking about, right? Those
Mhm. Inside the bucket.
inside the bucket as well, they create the virtual addresses or virtual directories basically.
Okay, you can create, so you have a field, you can uh, go into the another directory and just actually see that the files belongs to that virtual node or virtual
Yes,
directory.
No,
yes,
no.
Okay,
yes.
got
I
it.
mean,
They
even
are more
S3
like
also, I think it's a flat structure only. It is not a tree structure.
which one?
S3 also, it's a flat structure only.
So I think it's a so this virtual directory or tree structure we are talking about. It's more like an abstraction layer that they add. On a storage level, it stores it as a fat file, but on a high level, like from a user perspective, it looks like a tree structure, like or like we can call it like a directory structure.
And
Yeah.
how do we know that, I mean, they store as a flat file? They publish that, or what?
I would maybe if I find out the paper or like the articles that I read it, I would try to share those maybe.
Okay, because I know that, I mean, that's the way actually to store that.
Yeah,
I have worked in my experience. I have worked on that system, and this
yeah.
is how they actually store it.
And also like the primary structure is the fat file structure, but I think these are add-ons that were added much later. I think I remember for sure like they brought in this virtual directory structure much later. I remember reading this base specifically.
Mhm.
Or I guess there was some AWS Invent conference talk as well on this precise thing.
Okay.
Yeah, I think yeah, we'll discuss. We'll continue discussing on this tomorrow. Yeah.
Yeah, yeah. Okay.
And can you stop recording and start again?
Yes.